Okay, let's take a look at number 57 in Chapter 5. 57 says, the asteroid Icarus, though only a few hundred meters across, orbits the Sun like the planets. Its period is 410 days. What is its mean distance from the Sun? Okay, so we have Icarus going around the Sun, period of 410 days. We want to find out what the radius is. So when it says the average, the mean distance from the Sun, that's the same as saying we take the ellipse and make it into a sphere or a circle, and what the radius of that circle is. Okay, so we can start out with Kepler's third law here. So for the ones, I'm going to say that those are Icarus, and for the twos, I'm going to say those are Earth, and we're going to compare it to Earth again. Okay, so the period of Icarus over the period of Earth, that ratio squared. The radius of Icarus over the radius of Earth, and that ratio cubed. Okay, so what we want to do is solve for the radius of Icarus around the Sun. Okay, so to do that, again, we take both sides to the 1/3 power, or take the cube root of both sides. So we get the ratio, the radius for Icarus over the radius for Earth. The period of Icarus around the Sun, the period of Earth around the Sun. Okay, that raised to the 2/3 power. Remember, we took the cube root of both sides here to get the 2/3 on this side. So the formula for the radius for the orbit of Icarus around the Sun would be the radius of the Earth, the period of the Earth, or the period of Icarus, period of the Earth, that ratio raised to the 2/3 power. Okay, so we know what the radius of the Earth is. The period of Icarus around the Sun is given as 410 days. We know the period of Earth around the Sun, and we'll probably want to put that in days also, so that the units of days cancel out before we take this 2/3. Okay, and that will give us the mean distance from the Sun for the asteroid Icarus.